Hello everyone, I'm Vinay. I'm a software engineer. Hello everyone, I'm Vinay. I'm a software engineer. So I had always loved solving these problems, but recently because of my job and everything, I've been very busy and I've lost touch with it. So I actually used to do competitive programming during my college time, but yeah, recently I lost touch with it. So I'm just trying to get back into it. I just always enjoyed solving DSA. It's something that I love. So I was not like a very good at competitive programming or anything, but yeah, I used to do it very regularly. I and yeah, I'm just trying to get back uh, at least to the level that I was in college. And I heard that Striver SDE Sheet is very good to learn DSA. So yeah, that's what I'm going to start solving in this series. This series is not for like I'm not trying to teach DSA to anyone through this series. This is more for me, just live streaming it, trying to improve my presentation skills, my explanation skills, and just it will be a good discipline for me as well. And just trying something new. I was just getting like it was just getting very lonely trying so doing uh, coding alone. So just thought I'll share my experience with everyone. Then if you can just think that if you want to join me, you can also join me. You can just think that you are doing DSA with somebody with a friend, just enjoy the experience. So what I'm going to do, I'm mostly solving it on lead code, these questions, and as I solve it, I'll try to explain what I'm doing, what my approach is, and how I'm going to solve it. So yeah, let's start with the first question. It is already loaded. I'm stupid. Yeah. Yeah, so I'll mostly be solving in Python because that is my main language. That is something that I use on a regular basis. So let's start with this question. Given an m cross n integer matrix, if an element is zero, set its entire row and column to zeros. No store in place. Okay. The first thing that comes to mind is an m cross n solution where uh, like we just traverse the whole matrix and zero. We make its whole column and whole row as zero. I think that is what it is expected. That is more like n crossing because we're traversing the whole matrix and then uh, n plus m because for each zero we will traverse one row and one column. So by my approach, the complexity will be m cross n into m plus n. I don't think that will be an efficient solution. Let's see the constraints. It's only 200. So our solution will work. It's supposed to work. I'm just trying to think if there's an m crossing solution directly. Let's see what is in place is. Okay, so we are not supposed to make a copy of the matrix, we are supposed to do it in the same matrix. They have given some notes as well. They are saying that it's a follow constant space solution. These are just talking about the space. Let's not use any, yeah, across an extra space. So one thing that I correct is if I go with my approach, we traverse the whole matrix. Yeah. For example, let's take this. Let's take this. Start with 0. I make this column and this row as 0. But then when I go into the next one, I realize that, oh, this is 0 because we have just made it 0. Now that will cause an issue. We won't be able to track where the initial zeros were. So one thing we can do is we can just maintain a list which has the initial position of all the zeros, and then you can just make those rows and columns as 0. But that will be using extra space. We have said not to. One thing that comes into my mind is, I mean, these integers are, oh, so they can be negative as well. Values can be negative. Okay, let's start with the simple extra space solution, then we can build the better one. So I'll keep track of. So I'll start with keeping track of the initial zeros in the list. And I'll just iterate the whole matrix. Then got a 0. Nah, what am I doing? A lot of pain. Guy from magic. Coding standards. Sorry, I have very bad coding standards. Depending that concludes our initial zeros loop. Then yeah, I'll start with the destruction mode. I don't have to do it. I can do this also. But row comma column. That is a very bad idea. Let's do this around initial. Now we are why don't we row comma column, because I expect that we are going to get the rows. So why I did this is I put the row value and the column value of the initial zeros in the initial zeros matrix. So now for I in initial zero it will be a single I comma j value, and row comma column is equal to is I and column will be j. Row comma column equals kind of split. Now we start to iterate a whole row and whole column, and then nice. If I do for I in I think I should get an annual subject. No, it's fine. I just did length of matrix. So that is iterating over the rows. So I need to change the column value. No. The column value will remain same. The row values will keep changing. That will be matrix of. I'm stupid. I have used I here. Then I am trying to use I here also. Very good, Nina. Matrix of J, not only J, man. What is happening? J comma column, man. I can get it between sometimes. Matrix of J column equals 0. No, because we're looking the value 0. Then the same thing we'll do for all rows, for the corresponding row as well, for change range. See, I am very smart. Very, very smart. Wow. Yeah, the matrix row will be the same. We change the column values. Array, I'm sorry. This equals 0. I don't think we don't have to change anything. We don't return anything. We have to modify. What is modify? To modify the matrix in this. I think we have modified. Let's see. I'm stupid. Oh, nice. Yeah. As I said, I'm very smart. I don't know how to write a for loop, and I'm a Python programmer. Nice. Who kept me on job, man? Stupidity. Oh. Yeah. Yeah, I am stupid. No. Yeah, it should be done. Yes. Oh, finally, it ran without any errors. Seriously, who kept me on job? Oh, nice. Okay, so what will be the time complexity here? Don't say n into m plus n. No, this is n into n plus n. I will do that. So this loop will run for n because we are iterating over the row, and this loop will run for m because we are iterating over the column. So this together makes it m plus n. Now we have an outer loop that runs for the number of zeros. Now since these are initial zeros, it is possible that all the values in the matrix are zeros. In that case, we have m into n zeros. So in the worst case, this loop will run for m into n times. Now it becomes m into n plus m. So that's why it's n into n plus n. And we have also used extra space. We have used oh, now I realize we have actually used n into m extra space. That is very bad. A lot of people out. What I have just said, simple improvement to this, but still not the first solution. Constant space solution is difficult. Okay, I can try for the constant space solution. But it's too late for my brain to work. I don't know. Okay, let me think. Simple improvement to the core and plus n question not the best solution. Ability versus constant space solution. Constant space. How can we do this without storing the initial zeros? We don't know the zeros down. I think time complexity can't be improved. I mean, it might be improved, I'm not sure. We'll check the editor rules in some time. Hmm. How can you do this without using the initial zeros? So like, no, replace the zeros with something else, then there is a chance that they know that we can do that. That's why they have put 2 raised to 31 minus 1. That is, I think, the limit of the value. So what it means is that uh, an integer, like in Python, an integer can contain 8 bytes of data. Yeah. Okay. Sorry for that. Back. Yeah. So yeah. Okay. So this we were talking about this, right? Yeah. So why is 2 is to 31? Yeah. So why they have done this 2 is to minus 31 minus 1? They have done this because in Python an integer is 8 or 4. Yeah, sorry, 4 bytes. This is 2 is to 31, right? So that is 4 bytes. That is 1 byte has 8 bits, so 4 byte has 32 bits. That's why it is 2 raised to 32 minus 1. That is 2 raised to 31, and this minus 1 is for the limit. They have done this so that we should not be able to substitute the 0 with any other integer value, because then it becomes very simple to do it without sample space, because we can just substitute all the initial zeros with that value even well, and then yeah, we know that okay, this used to be a 0. In that case, we don't need as initial zeros matrix, and so initial zeros list, and then we can just do it normally. This is very clear. What should we do? Can we do it in constant pace? Okay, maybe we should check the editor again. How they are doing it. I don't know if I'm able. I should show the editor here. Okay. Why? We need to modify the given matrix in place. Space complexity needs to be worked on. Additional memory approach, I think this is the same thing that we have done. I think they have used a new volume matrix and copied the original array for checking where the zeros are. Yeah, I said 0 entries. I mean that is the same thing that I have. We have kept a set color row set and column set where all the zeros are, and then yeah. The time complexity of is O of n cross n. in Python, whatever. Okay, so they have maintained. So they have come with even a better so they have come with a better solution than mine. This is off and cross only because they have kept a row set and column set, and they have just putting for yeah, they have kept a row set and column set, and in whichever row or column zeros are there, they have just uh, put that. So if there's a zero in a particular row, they have put that row number in the row set, and the same for the columns. And then they have just iterated over the whole matrix. If the but then that is the same thing, right? Here it checks if I is in rows. Now that depends on how many values are there in the row matrix. So I don't think this is O of m cross n. This is not O of m cross n. They are no. So what they have done is they have iterated over the whole matrix. Then for each row and each column, they are checking if that is present in the rows or the columns column. Sorry, rows or columns set, and accordingly they are making the value 0. But here also the same thing. They are iterating over R or row and column. This is m cross n. Now this is I in rows. This basically checks if I is present in rows, and that is a search. And search is not search never happens in constant time. Even if it is a set, it will at least take log n time for searching. Maybe a hash map here, but yeah, it's not off n cross n. This will be off n cross n into log n plus log n. But still better than my solution. Let's see how they are doing off one. Rather than using use the matrix itself as indicator. How are they using the matrix as the indicator? I think it's the first cell of every row and column as a flag. This flag will determine. Okay. Okay. So for each, let's say for each 0, so in whichever row and column it is, they are just marking the first element in that row and in that column as 0. So now we know, okay, we have to, oh, that's smart. That is smart. Good solution. I like it. So let's try solve it. I'll show how to. I haven't seen the whole thing. I hope I don't mess it. Now, after saying I know how to solve it. Okay. Yeah. So what they are doing is first they are iterating. Find the range. Why is this so slow? Length of matrix. It's iterated over the whole row. And for J. Range, length of matrix, and this is iterated over all the column, the whole column. Now we just need to know if the current entry is 0. If it's 0, then we mark the first element of that row and of that column as 0, because anyway we have to make the whole row and column 0. In this way, when we iterate, we just have to iterate the first we just have to iterate the first column with the first row, and wherever we get 0, we mark. So if let's say if we are iterating the first column and we found a 0 in the second row, we make the whole second row 0. That way we keep track. That is very smart. Okay, so we do matrix of 0 j equals 0, and what does that mean? Oh my god. We do matrix of 0 j equals 0, and then we do matrix of I j. Why j? I0 L0. Now when we go searching, okay, let's say for I in range. Now we don't check the let's say we are checking the first column, and in from check the first column we will get to know which rows we have to make a 0. We don't check the first row, because in the first row also we have marked which columns we want to make 0, and anyways automatic, and yeah, that's why. So the first row and the first column will be checked later. Yeah, at the end we just check if 0 comma 0 is 0, then at the end we just make the first row and first column is 0. So we will do first for I range I comma matrix, and I'm so smart. This way we iterate the first column, and we just check if matrix of I and 0 equal to 0, then we get into a better business. Sorry, for j in range. Let's length of matrix of what is this? Come on now. The matrix of I will be the same, and the j will be 0. What is this? Okay, Baba. They need a space after column. And I know I should not be working with so bad coding standards. We do the same thing for the column. Okay, so here this will also be it's 0, then we take the whole column. It is 0. Now we had preserved our first row and first column because we did not want to uh, lose our tracking of the initial 0. So now what we are going to do is we are just going to check if 0 comma 0 is 0, if matrix of 0 comma what am I doing? 0 comma 0 is 0. If that's true, then we make the first column and the first row is 0. And I can just copy and paste. It's the same thing. just need to write 0. Double thing. Okay, I should not do this. I should keep the name proper. This is J because we are iterating over the whole column, right? So we are iterating over the whole first row, right? So the J, its row number will be 0 and J will keep changing. Like basically we are doing the reverse of what we are doing above here. So yeah, to avoid confusion, I'll do it like this. Short J, this will be 1. Instead of J, this will be 0, not 0. This will be I. Enter, mana sih kan enter, अरे यार, I don't know the laptop is lagging. Okay, let's try running. Let's see how many syntax errors, comparison errors. No syntax error. Nice. I was not expecting that. Let's try submitting this, and I have got the wrong answer. Very nice. As I said, keeping track becomes difficult here. Everything is fine, but yeah, keeping track of the first row and first column will be difficult because we don't know which. So what we can do, right? We can just have an initial check, because if there's no such thing, then we don't have to do anything. We just need to keep an initial check before doing anything that. Let's say we say first element equals false if matrix 0, 0 equal to 0, then first underscore equals true. What we do? Yeah, we did the first L equals to true. Why is this showing like this? It's not a local variable. I have to find it here. Yeah, man, come on, man. What are you trying to achieve here? This is first element here. We do this only if the first element is 0. First, that's true, then only we run this else. We say it has बहुत शुक्रिया and now submit. And now we get a wrong answer again because I'm stupid. Now what? I did some mistake somewhere. Yeah. Okay. I don't need this in that case. I don't know these ones. Because we're already checking if the initial element is 0 or not above. That's why the partial D is there. We don't need this. It's the indentation of Python will start dancing chinga 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 chinga. Arey, still wrong answer. Why? Some issue in this. Okay, I know I got it. So if first element is 0, then we want both the row and column as 0. But if first element was not 0 and it was made 0 by someone else, then we just want the particular row or column to be 0. Makes sense. So, I'm going to copy this part and I'm just going to control 0 until I get the initial part. So we will check for the first element.